So here's our dive plan. So first of all, I will little introduce myself, because probably not all of you know me. I come from Europe, so we haven't had too many options to interact. Then I will be talking briefly about the habitats, underwater habitats, with more focus on the hydronaut project, which I'm part of. And I will also outline future activities that are basically on our pipeline for the future. So, a little bit about myself. I'm located in Central Europe. You can find me basically traveling between Czech Republic and Slovakia, where I live, but I work in Czech Republic. From an educational point of view, I'm an environmental physiologist, so I deal with processes in our body. And I spent the whole career, my scientific career and personal career, being scuba diving instructor and also hyperbaric medicine researcher and teacher. I have been teaching hyperbaric medicine at the Faculty of Medicine Ostrava in the Czech Republic. And as I said, more than 20 years I have been also scuba diving instructor with more than 15 different qualifications. Basically diving was something that opened the world. Slovakia as a country has no access to space. We don't have a space program, so it's difficult to be space enthusiasm over there. So for me, naturally, as a kid, was like, what is the next fancy stuff? I said diving, so I started diving. And basically diving allowed me really to go to different places. And diving also was something that basically, when I look retrospectively, I realized that I did a couple of analog studies on myself, but at the time I didn't consider them as analog studies. One of them, just to mention it, was under the Pearl expedition, which took place in Greenland in 2015, where I was principal investigator of divers. Basically, the expedition was above the polar circle in Greenland. The vessel was frozen in the middle of nowhere. And we were several divers over there, diving very difficult dives, I would say, down to 50 meters below the sea ice in water temperature of -2 degrees Celsius. And I was taking measurements on divers who are diving underwater and also post-dive and pre-dive, of course. This all together, I mean, diving, as I said, is my passion. I'm also representative for DAN Europe. Probably who are divers of you, you know the Divers Alert Network. It's a worldwide leading organization promoting safety and research on divers, and I'm area representative for Slovakia. I also joined several fancy projects on diving. For example, just to mention one, a fiber project, which was Maria Curie project in Europe. It's a special kind of project running to improve education of students. But for us, in this project, I mean, diving was a tool to improve quality for the students. So we spent 2.5 years, actually it was 4 years, I was there for 2.5. We spent 4 years just studying decompression sickness. Of course, probably you heard about the hydronaut project, which has quite a long story. The initial idea of underwater habitat in Czech Republic started like 13 years ago. And it became operational in 2020, and naturally I got involved in these activities because of my expertise. And since then I also joined Analog Astronaut World. I participated in several underwater missions, or I am participating in several underwater missions in Hydronaut project. I also was a flight planner for Amateur 20 mission organized by Austrian Space Forum, which took place last year in Negev Desert in Israel. I see some faces from this project here. That's very good to see. And I also joined some missions, some virtual missions organized by Habitat Marte in Brazil. So when we look, let's say, in the future, and we talk about exploration of either Moon or Mars, we know all these biological challenges. But I think personally that the main challenge will be ourselves. And it will be how we can deal with situation we haven't dealt before. How we will deal with situation that we will not see Earth anymore, or we will see it in very, very small. Let's say it will be just a very, very small point somewhere on your horizon. And to do so, of course, we need to do a lot of investigation, a lot of research, and we do it, and you all know it because you are part of it, and we have different analogs where we study different aspects, and we also study different complexities, and basically we can distinguish two basic types of analogs. One is more operationally oriented, for example, like Amada 20 was, where really the program and the whole focus of the whole mission was really like to be living on Mars, while some others are more oriented on environment. So just to mention, it's probably the Concordia and of course underwater habitats. So why are underwater habitats so good to study the extremes, because we are talking about ice environment, and really this E as extreme is really the best characterized by underwater habitats. So underwater, especially during AVAs, you can really change the gravity. You can really mimic different kinds of gravity, you can have these microgravity effects during AVAs, and you can really have like lunar or Martian gravity over there. Of course, being underwater or in space, you solely depend on your mission control center and all life support systems. And what is the most important from psychological perspective, that in both environments, underwater and in space, you don't have opportunity to have immediate access to surface. So basically we are dealing with this delayed or remote emergency situations, or delayed access to, let's say, to the rescue. So why is it so? It's because underwater we are using special technique which is very known in commercial diving. It's part of the decompression diving, and it's called saturation diving. I don't know how many of you are divers here, certified. Okay, quite a lot. That's great to see. So probably you know when you dive, you consider about two factors. One is the depth, and second one is the time. So more time you spend in the depth, probably will trigger some obligation to make decompression. And at some point, when you dive for a substantial period of time at certain depth, the decompression will be impractical because it will be longer than the dive itself. And in this regard, we have learned that if you spend certain time at certain depth, your body becomes fully saturated, and basically at the end of the exposure, you just do one single decompression. So basically you can stay infinite time in this depth unless you change it. You can stay there, and then you just do the final decompression. This is a technique which is really employed in the commercial diving. Of course, it's not done underwater, it's done on surface, so usually in commercial diving you see such kind of systems present on specialized vessels with the divers inside. It's usually 24/7 operation. Usually they have like 3 teams running basically 3 shifts per day with 8 hours shift, and they live compressed under the desired pressure, this pressure where they will be working. So for example, this pressure inside of such chambers can be like 220 meters, and then for the operation they are transferred by such bells underwater. It's still pressurized, so they keep the same pressure inside. They are transferred to the working depth, and they work there, they weld, or drill, whatever they do. So the principle is quite known, I would say quite explored, and has excellent safety records, because of course it's commercial diving, and there are a lot of interest in safety, and it's really paramount of these activities. So we use something similar also in our underwater habitats. So currently, I mean, of course we can have a little bit discussion whether they are all operational or not, and to what extent. But let's say currently there are 3 underwater habitats present worldwide. 2 of them located very close and here in the United States. It's in Florida, it's either the Nemo or Jules. Both of them are located in the ocean, so it's salt water. And they are located in, I would say, tropical areas, so it also brings a different perspective in terms of water temperature, for example. while Nemo is quite deep, it stays basically, I mean, the bottom part of the habitat is roughly at 90 meters. The storage depth, so the depth where the astronauts or aquanauts are living, is at 30 meters. Nemo can accommodate up to 6 aquanauts, if I'm not wrong. If someone was a member of one of the crew, I will be very glad to discuss it a bit more in details. Of course, you can do AVAs in all habitats. What is very interesting is that in Nemo, basically Nemo, there is a cross-section of it. The part of Nemo serves as a decompression chamber or recompression chamber. So they can pressurize it underwater, they can change the depth, they can also change the breathing gas. So they can really do decompression in the habitat and then they just escape to the surface. So decompression, just for your idea, for Nemo, because of the depth, it's roughly around 15 hours, so it's quite long. For Jules, Jules actually it's an underwater launch, so it's more used for also different commercial activities, and it's also multi-compartment habitat which can accommodate up to six people. The depth is a little bit shallower, what means that in Jules usually they don't have this decompression obligation. So you have a certain depth where you start to be saturated and you need to make a saturation decompression, and you have a certain depth where you don't need it. And basically Jules is just below this border, so basically you can escape from the habitat in any day, in any time, without need of any, let's say, substantial decompression procedures. And there is one habitat located in Europe, which is called Hydronaut. It's located in sweet water, it's located in quarry. You will see the pictures where is it at the moment. The habitat is very small, it's just a single compartment with something like 10 square meters and 20 cubic meters of the inner volume. So it's a really small one. And despite that, it can still accommodate between 2 or 3 aquanauts. We have, and we'll be talking about that, we have several missions where we were 2 or 3 inside. What is also quite interesting about this habitat that, of course, the pressure inside and outside is similar. So it means that you need to go out in a wet way. So and you need to do all the decompression in a wet way. So basically, we do all the decompression either in the free water, open water, or we have another bell where we just shelter for a while and we do the decompression. Hydronaut itself is a mobile platform, and this is really the most distinguishing feature of the Hydronaut compared to the other habitats underwater, because it's mobile, so you can really transfer it. It's a little bit heavy, it's like 35 tons, but it's still movable from the place to another. Operational depth for the Hydronaut is down to 20 meters. At the moment, we are doing experiments in the range between 7 to 9 meters of the depth. So we are already in saturation mode, and we really need to have this decompression obligation. Yeah, underwater habitats, besides this extreme feature, so being underwater and to don't have immediate access to the surface, are also very good to mimic other situations. One of them is really that you don't have too many windows, so basically you can really play with circadian rhythms of the aquanauts. So basically you can put artificial light, you can really make them totally isolated, and probably it's also good, let's say, good platform to maybe to introduce also this Earth out of view phenomena, because underwater you obviously have feeling that you don't see anything comparable to Earth. Of course, naturally, all the habitats have a little bit problems with a little bit elevated CO2 levels. So this is also another part, physiological factor, which can be studied because it can have a tremendous effects on the let's say, on the crew, on the performance, and also on the safety. Especially in our habitat, since it's located in a sweet water, we have huge temperature oscillation through the year. So, for example, in the winter, the lakes are frozen, and in summer it can reach like 24 degrees Celsius. So you can also play with the ambient temperature and to study the effect on the crew performance as well. And of course, since it's very, very small, you have some limited restriction to hygiene, food, and of course, in the most complex situation, you can even mimic some communication delay or communication outage. For example, we already experienced one in a hydronaut, what was really significant change in our daily life when you are underwater and you suddenly don't have a connection to the surface. Maybe you are asking, so why these crazy guys somewhere in Europe in the middle with no access to the sea, how comes that they try to do something what is probably more common in salt water, in the oceans? Yeah, the answer is very simple. It's because of the heritage, and it's because that since, I mean, if you look in the past, in the history, at that time it was still Czechoslovakia, we haven't had access to the sea. So as divers we wanted and we explored opportunities in our sweet waters. And in 1967 there was probably one of the first unmanned missions. I think Leszek, you were talking about it yesterday during your panel, that you are trying, or you were mentioning that who was the first doing the first unmanned mission. So just to give you another puzzle in your so this was like in 1967, where two people spent 4 days, so 100 hours in 25 meters in the habitat. So in habitat you can see here. What was really, I mean, I cannot believe that it was doable at that time, that this dive, this 100 hours dive, took place in a lake in November. In November it's already freezing in our country, so the water temperature was close to the freezing point, and they spent 100 hours in 1967. You see that really the inside was quite Spartan, and the habitat is still at the place. So if you are a diver, you can still dive there, and you have something on your remarkable in your dive logbook. Yeah, so this was the history. Now the presence. So hydronaut design is like you can see on this picture. So basically it's a single compartment, single vessel, which has certain legs, which is like sort of counterbalance, because of course you need to balance the inner volume and the buoyancy. It's entered from bottom, so there is a manhole where you can enter, and there is also another lid on the top. So basically, once the habitat is floating, you can enter from the surface, or you can, if it's immersed, then you can enter from the bottom part. Habitat has a platform where it's located on the surface when it's not in service, when it's not in mission. The habitat itself is quite small. It's actually, I have wrong number, it's not 25, it's 20 square cubic meters. And it can be entered once it's underwater. It can be only entered in a wet way, so you need to be a diver and you need to have proper equipment. Inside, as you will see in a minute, the habitat is equipped with Wi-Fi, computers, sensors, and different other instruments. Project itself, I forgot to mention, I returned just for a second. Project itself is funded, co-funded by European Space Agency via Business Incubation Center in Prague. So, and the project, this incubation project is, I think, ending this year. So, we got support also on this, let's say, upper level. The first mission took place in 2020. It was a mission which was already sort of breaking, I would say, because the first mission has already been the first Czech record. So they spent two people, two aquanauts. They spent 7 days underwater. So at the time it was immediately the record of the Czech Republic. So in the first shot you already do something really so amazing. Here you can see also Matthias, who is the founder of the project. So he's not only founder, but he's also, let's say, a very passionate diver, and he really loves to be involved in all the activities. The second mission took place last year in June. I was part of it as an aquanaut. In this time it was a 3-crew mission, and it was a relatively small mission which was supposed to last 48 hours underwater, because the scope was to show capabilities the habitat in terms of doing science underwater, because you can imagine that if you do something underwater, it's slightly different than when you do it on surface in any kind of habitat, because obviously the instrument needs to be adjusted for the underwater or waterproof use. At that time, the water temperature was 7 degrees Celsius, so quite cold, still quite cold. And inside the habitat we had only 12 degrees of Celsius temperature with 100% humidity. And this was also one of the factors when while mission should be, was shortened. So originally we were supposed to spend 48 hours underwater, but then we shortened it for the safety reason just to something like roughly 43 hours. Because the last thing what you want to do when you do in water decompression from saturation is to be not in shape. And we were not in shape, because really we pushed to the borders and we said, yeah, we cannot do it anymore because really now it goes on safety. Just for you who are experienced divers or have an idea about what was what was the state, basically, if you do decompression from saturation, you need to breathe oxygen, and oxygen under elevated pressure. And if you do it for a certain amount of time, you can develop acute hyperoxia, or if you do it in a let's say with higher partial pressures. And such acute hyperoxia, it's really something what you don't want to experience, because you get seizures, you are unconscious, and then basically game over. So let's say some of the contributing factors are like to be tired, to be hypercapnic, so to have high elevated levels of CO2, and temperature is also a contributing factor to develop such problems. And of course, for us, we were a crew of 3, and we needed to take shifts. So basically, every time one of us was awake through the night, so two guys were sleeping. So you have tiredness. We had an elevated CO2 level, so we have hypercapnia, and of course it was cold, and it was cold, believe me. We were also hypothermic, so this was all the reasons why we shortened the mission for the safety reasons. And also another contributing factor was that the mission start was delayed, and so it would mean that decompression should be carried out in the night. And again, doing it in night, maybe not the best idea. So, but in general, it was a very successful mission, despite it was shortened, because we did a lot of experiments underwater. We did some studies on the microbiological contamination of the habitat, because we are talking about sweet water, so we have more, let's say, contamination than, for example, you see in the sea conditions. We did some telemedicine experiments. We were basically testing platform for one of the experiments which was later used in Amade 20, so this MSG experiment was initially carried out in the hydronaut. I personally was studying effects of hypercapnia and cold environment on our cognitive functions as part of my diving research program. And of course, and this is very important to say, that due to my expertise, we were also able to study decompression stress. And this is very important, because if we study decompression stress, so basically the stress what is induced by the dive to diver, we can adjust our decompression procedures and to make it very, very safe. So this was really extremely useful, and the data which we gathered will be used also for the future missions. And when we talk about the future mission, sorry. So yeah, just a few pictures about how it looks like inside. So this is the manhole you need to enter the habitat from the bottom up. It's quite small, I would say. The diameter is roughly 80 centimeters, and basically you need to climb with all your diving gear. So you can imagine that if you have something like 40-50 kilograms of your diving gear on your back, it's not so easy. Of course, we do all the dives in dry suits because of the temperature and because of the contamination. So yeah, try it sometime when you are fully dressed in dry suit with all that you can just stand up from the water. It's really difficult. So when you go inside, it's a single compartment with just these 2 windows. As you can see, you immediately have a different view on the Earth because you only see the green in our case. And for me, it was really like sort of transformatory, because once I entered the habitat, first time for me, I immediately had the feeling like I'm completely somewhere else. maybe the same like yesterday it was said that it takes you 8.5 minutes to be in weightlessness. For me it was really like maybe 2 or 3 minutes I entered the habitat, and immediately the feeling was like, wow, it's something really extraordinary, it's absolutely different. So I mean the container inside is divided by this manhole to the two parts. One is more living room, so it's you have the 2 bunks. You have a small kitchen here. Of course, it's also used as a sort of restroom. And on the other side is a communication center with a surface and area where you do the experiments. Since the habitat is very small and you do several experiments in parallel, it really became impractical for us to communicate everything through the mission control center. Because of course you have 3 people doing 3 experiments and you cannot talk all each other through each other. It's just not a working solution. So as a part of the project, there was a special software developed which allowed us to basically follow our task as aquanauts, and also to be aware of the surrounding environment, so like temperature, CO2 level, etc., etc. So this was very useful for us, and really saved a lot of time in terms of communication with the mission control center. Yeah, as I said, we did a lot of experiments, and the habitat itself is equipped with some basic physiological instruments, like for measuring hypercapnia, for example, or some telemedicine stethoscopes and so on. We as aquanauts were also completely wired, so we were monitored for our, let's say, physiological signals like heart rate, breathing rate, skin conductivity, etc. Yeah, we also did AVA in a hard helmet, so you can see now the visibility in water, so it's really what makes it to be tricky to do some activities. But of course you can do it in this hard way with a hard hat, or you can do it also in normal way as a normal virus. Yeah, we are just preparing for the 3rd mission, which will take place in August this year, which will be a 7-day mission, which will focus more on psychology, and we already did like 3 days testing with the psychologists to basically to more understand what are, let's say, the requirements for the future crews. And this project is supported by Technological Agency in Czech Republic. Of course, and it's really a pleasure for me to announce that, after this mission, I'm taking responsibility for conducting annual missions in this habitat. Habitat will be also moved to Slovakia for the better conditions, better water conditions, environmental conditions, and this is also an opportunity for you to join the project. And if you are interested to become an aquanaut or to be participant in one of the studies, just please reach out to me, and we definitely find a way how to do it. The habitat itself will be located very close to Bratislava, also capital city of Slovakia, close to Vienna, so it's easy to basically to come there by plane. There will be 24/7 surveillance, there will be a lot of safety measures, decompression chamber, medical staff, etc., etc. And of course it's open for all participants, researchers, potential sponsors, or whoever wants to join the project. And one of the last things I want to mention, that of course you are maybe asking, so how can I join? Because I'm just a, let's say, open water scuba diver, and this is definitely something a little bit more challenging. As I said, I am a scuba diving instructor. I'm also expert in hyperbaric medicine, and currently I'm developing a special kind of aquanaut training, especially used for these conditions. So it will involve trainings in a cold water diving, in saturation diving, of course full face mask diving, and we will also be using oxygen as a decompression tool. So this is everything what you can learn in this course, which I hope we'll be launching later this year. And that's it from my end. Thank you very much for your attention.